Hi and welcome to everybody. This new video will be about inequalities. Of course, we continue to use the 5 points we developed to study inequalities. We simplify if we need. We analyze the function to cut it into pieces. The pieces will be elementary function we already know. After, we obtain the domain of the function, studying the domain of the elementary functions. After, we study the sign of the elementary function to obtain a graph of the sign of the elementary functions. At the end, we can graph the results for the function we are studying, when it is positive, when it is null, when it is negative. A few things to remember. e to x is greater than 0. It's strictly positive for every real x, for every x belonging to the real number. Every real number will make e to x a positive number. e to 0 is equal to 1. About the sign of the elementary function e to x, we know that if x is greater than 0, e to x will be greater than 1. If x will be less than 0, a negative number, e to x will be less than 1. Anyway, it is a strictly crescent function. Continue our study and look at a little more complicated function, e to x minus 1 greater than 0. This study is quite simple. The domain is every real number. We know the sign of e to x. It's always positive for every real x. But now we have to subtract 1. This means e to x, we are looking for the solution of e to x greater than 1. But we do know from our study of the elementary function e to x that e to x will be greater than 1 if x will be greater than 0. So our result will be e to x minus 1 will be greater than 0 for every real x greater than 0. Here the results. This is the positive region, this is the negative region. If x is equal to 0, this function will be null, because e to x will be equal to 1, 1 minus 1 will be 0. A little tips for teacher, a teacher tip. It is very easy to use this function e to x during your lesson, but you have to remember how to use it and the way it can help you. We can use e to x to quickly propose to our students a number of inequalities which looks very difficult, but they are not, because with a little reasoning we can solve them. For example, e to square x minus 1 greater than 0 is almost the same exercise we have done right now. We can prefer a little effort from our student, a little calculation, trigonometry one, as here in this equation. So we can propose something like this. It could be square sin, cosinus, square cosinus. It's the same. Also this equation, also this inequality can be easily solved, as we will see. At last, but not least, we can write down very difficult expression that looks very, very scary to our students, but they are not. Again, this kind of exercise can show them to think, not to go and make calculus, and so on. Because with a very little reasoning, we can solve this kind of equation. Okay, now, after a few tips, we can look at this exercise, a very simple one. E to x squared greater than 0. It is so simple that we can do the two steps, analyze and domain of the function, together. What are the elementary functions which makes up this equation? E to y greater than 0, and e to y is defined, as we know, for every real y. The other function which makes up this big function is squared x. Squared x is defined for every real number, and it is greater than 0 if and only if x is different from 0. Otherwise, it will be always greater than 0. Note, every real number we put in x squared, we obtain a real number. That means, if I put here 1, 2, 3, we obtain a real number. If we put inside here -1, -2, -3, -pi, we always obtain a real number. This is very important because we know, again, second step, we now are thinking about the sign of the elementary function which makes up our function, and we want to make a graph. As I told you, for every real x squared is a real number, but for every real number, e to y is greater than 0. So, our function e to squared x is greater than 0 for every real x. Okay, so fundamental point is e to y is greater than 0 for every real number. What we obtain from squared x is a real number, so our inequality is always verified. Okay, now get into something a little more difficult, a little more challenging. E to squared x minus 1 greater than 0. That means we have to look for which values of x squared will make our e to x squared, our function, greater than 1. Let's look to all the steps we are used to do. Simplify. There is no need to simplify anything. But we have to analyze. Again, we obtain elementary function e to y, x squared, the sum, -1, and the constant 1. As always, we do not have to look after a lot for sum operator and the constant operator. We have to study the behaving of x squared and e to y. Let's look for the domain. This is a very easy one because e to y is defined for every real number, and so the same is for x squared. They are both defined for every real number, so our function will be defined for every real number. Let's look at the sign. We know e to y will be greater than 0 for every real number, so no bother about this one. Let's look at this. X squared is greater than 0 for every real number, but different from 0. If we put inside x squared 0, we obtain 0, and 0 is not strictly greater than 0. So we know that our function will be x squared, will be greater than 0 if and only if x will be different from 0. Now we will make the graph of our elementary function, and combining the graphs we obtain, we will arrive to our results. Note that probably we don't need to make the graph in this case, because e to y is greater than 1 if y is greater than 0. Okay, so we have to look when y is greater than 0. But who is y in our exercise? Y is x squared. So we have to look for when x squared is greater than 0. But we know this. We know that x squared is greater than 0 for every x, every real x, different from 0. So our results will be e to x squared will be greater than 1 for every x, real x, different from 0. And this is the graph. You see, it will be positive for every positive number. It will be positive for every negative number. It will be equal to 0. It will be equal to 0 only if x will be 0. Let's change to another exercise. Same fashion, but different exponent. Now we are looking at e to x to 3 minus 1. That means we are looking for solution of x which will make e to x to 3 greater than 1. No need to simplify. We analyze the function to cut into pieces elementary function. We obtain e to epsilon x to 3, domain for every real number. Design, now it's different from last exercise. E to y will be greater than 0 for every real y, but our function x to 3 will be greater than 0 if and only if x is positive. We note that e to y will be greater than 1 if epsilon will be greater than 0. If our y is x to 3, we are looking for the solution, the value of x, which will make x to 3 greater than 0. Id est, we are looking for every real number positive, greater than 0. This will be our solution. Results: e to x to 3 minus 1 will be greater than 0 for every positive number. If we use 0, we obtain e to 0, it's equal to 1, but 1 minus 1 will be 0, and 0 is not greater than 0. We obtain the same results as e to x.